Okay, welcome back, and in this part of the review video we're going to start with problem 17, which says sketch the graph of a rational function showing all asymptotes, vertical, horizontal, or oblique, and their intercepts. Okay, so these are the problems that were assigned. Okay, we're going to start with 33. Since the powers are the same, it has a horizontal asymptote at 2x divided by x, or at 2. So if we go by that, we have a horizontal asymptote at 2. We're going to cross at y equals 2 here, horizontal asymptote. And if we look at the bottom, x equals 0 is going to be our vertical asymptote, which is this thing. So we have horizontal and vertical asymptotes at those places, x equals 0. So those are our horizontal and vertical asymptotes. We don't have any oblique because the power on the top is not bigger. We will have in 36. Alright, so then what we want to do is we want to figure out the x-intercepts if there are any. So what we would do there is we take this function and set the 2x minus 6 equal to 0, the numerator, and x would equal 3 there. So that means it would cross at 3. So our graph would have an intersection here point of 3. Okay, and then what we would do is we plug in a couple more values. I'm sure that this is going to go this way up to the asymptote. We would try a couple more values in there, and since this is an odd function, I'm guessing that this is going to happen the same over here in this quadrant. Alright, so let's take a look at that. Let's plug in a couple more values here for x and r of x and see what we get. Alright, so we know what 3 is. Let's try 1 and 5 on that side, and we're going to try the over here on the negative side. We're going to do -1, -3, and -5. Just going to figure out what those are. So we put 1 in there. That's going to be 2 times 1, which is 2. So that's -4 divided by 1. So -4 here for this answer. 5 times 2 is 10, minus 6 is 4. 4 divided by 5 for this one. -1. So that's -1. So -2 minus 6, -8 divided by -1, which would be +8. -3 would be -6 minus 6, so it would be -12 divided by -3 would be 4, and -5 would be -10 minus 6 would be -16 divided by -5, so that'd be +16 over 5. Okay, that's 3 and a 5th. Okay, so we have some points. Now we can guess kind of where it is here. 1 is -4, so it goes through here. 5 is 4/5. 3, 4, 5, so it's right about there. So this does go through those 3 points, and it approaches those 2 asymptotes. Okay, we know -1 is 8, so here's 2, 4, 6, 8. So -1 is 8, -3 is 4, so that's -3, it's right here, and -5 is 3 and 1/5. There's 2, 3 and 1/5. Okay, so it's like that. So it's approaching the axis here and bending upwards that way. So that's a rough sketch, and it gives you the intercept of 3, 0. Alright, moving on to this one. This one is x plus 2 divided by x squared minus 2x. It's factored, so that's good because it'll help us find the asymptotes. So this is also this one has a y asymptote at 0 because this is smaller than that one. So we have a horizontal asymptote at 0 right here. Y equals 0. And we have two x asymptotes at when this is 0. So x is equal to 0 or x minus 2 equals 0. So that's going to be at x equals 2. So we're going to have two asymptotes. One's going to be at 2, two vertical asymptotes. One's going to be at 2 and one's going to be at 0. Okay, we have the two asymptotes here. Okay. All right, we don't have any oblique because we don't have any power, and the top has to be bigger. All right, now we need to find the intercepts. So the only x-intercept is at -2. So we set the numerator equals 0, and then we get x equals -2. So it crosses here at -2. Okay. All right, so we need to get some points here. So that's all we have there. So we need to find some values so we can figure it out. There's not much else here in just the asymptotes. So we need to plug in some points. So let's start with -1, -3, -5. Okay, and then we're going to do, also we're going to do 1, 3, and 5. All right, so we plug those in. -1, it's going to be +1, and on the bottom we're going to get -1 times -3, so that's going to be -1 times -3, so that's +3. On the top we're going to get 1/3, so we get 1/3 for -1. -3, so you're going to get -1 on the top over -3 times -5, which is -15, well, +15. Okay, and then -5 be -3 over -5 times -7, which should be 35. Okay, so it looks like at -1 you're at 1/3. So you're right here. So it looks like it goes up here and then approaches that asymptote. Then this one goes really close to this point and then just stays close to this asymptote. It just gets closer and closer. It kind of just, it crosses, then it gets closer to that asymptote. It's just going to approach 0. This is getting smaller and smaller as we go. All right, let's try 1 here. 1 in this thing is going to give you 3 over 1 times -2. Wait. 1 times -1. So -1. So you get -3. So 1, -3. Okay, that goes here. 5. 5. Wait, that's 1. Okay, 3. 3 is 5. 3 and 3, that's 3 times 1, so that's 3, so 5/3 for number 3. And then 5 is going to be 7 over 5 times 3, so 7 over 15. Okay, so what happens here is that this is -3, then this one is 5/3 at 3, we're at 5/3, so that's almost 2. And then we're going down, so it has an asymptote. It looks like this. Okay, so this one must go like this. It has to. And I don't know where it turns. I'm not sure where it turns, but it's got to turn and go back up because it doesn't cross here or we'd have a intercept. So I'm not sure if this is the lowest one. We'd have to try some other points here to figure that out. Okay, this would be my best guess on that problem without plotting more points. All right, 36. All right. It has two vertical asymptotes at 2 and -2. So we take the x cubed over x squared minus 4. We take the denominator and we factor it. So it's got vertical asymptotes at x equals 2 and x equals -2. All right, then we're going to, since this power is 1 more than that, we're going to divide. Do our long division on this to find our oblique asymptote. It's going to go in x times, so that's x squared minus 4x, and our x cubed minus 4x. We're going to subtract. We get 4x here, and this doesn't go into that, so this is our oblique. Our oblique is y equals x, just the part that went in evenly. So we have an oblique, and we have two vertical asymptotes. Okay, so when we draw in the two vertical asymptotes here at 2 and -2, and the oblique asymptote is 45 degrees here at y equals x, then we're going to need to plot some points or figure out some values to plug into the function so that we can graph some points. So we know that the numerator x cubed equals 0 means that that 0 is a value. 0, 0 is a value. So it does have a 0, 0 value. If you plug in 0 to the function, you get 0. And let's see, let's try some other points. Make a little chart, your x and your y chart. We're going to do 1 and -1. And then we're going to do 3 and -3. Okay, so 1 in there is 1 cubed over -3, 1 over -3. -1 is going to be -1 over -3, or 1/3. And then 3 in there is going to be 3 times 3 is 9, 27 over 9 minus 4, which is 5. And the same thing is going to happen here, but it's going to be -27 over 5. So that's going to be 4, and that's going to be actually 5. 5 and 2/5. 5 and 2/5. All right, so 1 is going to be at -1/3. This one's going to be at +1/3, so it's going to go like this towards the asymptotes. 3 is at 5 1/3. 5, that's 2, 3, 4, 5. Wait, 3 is 5 2/3, so 3, 1, 2, 3, 4, 5 2/3. So this one is going to go like this towards the asymptotes. We're going to have the same thing happening down here with the other asymptote. So those are the three pieces that you should have right there for that point. So that's problem 17 in graphing those three types.